In this lecture, we will implement two-handed grip with a preserved ability to carry the object with one hand in different ways. First of all, let's open our grab component. And because right now we're gonna have different grab components per one object, I wanna introduce one more variable called priority. It can be very useful for us in the future. With the approach I want to show to you, we will manage the grab externally to some extent. So in order to achieve this, we need to get the code that internally performs the grab specifically and convert it into a function that can be called externally by the component we'll create later. So as you can see right now, we just have all this code as one simple function. Let's just rename it to something like perform grab. Let's quickly fix inputs because there should be a motion controller as an input there. And now any external entity will be able to call the perform grab on this component without triggering the code that comes next that performs the notify, the haptic feedback, etc. That's going to be useful for us for the cases when, for example, one hand drops the object and we have to perform the grab by the other grab component that technically already grabbed the object. So we don't need notify or haptic feedback, but we want it to perform grab. So here we have our perform grab function. As you can see, the motion controller is going to be used as a input variable here, and we can proceed. Now let's open our pistol blueprint. Inside of it, we're gonna have to add one more grab component. But first, let's add one more socket for it. Before we were using this grip bone and the grip point was attached to it. But this time, let's create a socket on the root bone. Let's call it far grip. And right now it's here, but it should be somewhere here. We will adjust it better with the skeletal mesh. Remember about the scale, because we have this gun scaled to 0.5 in the level. Now let's adjust the transform of the socket so the hand will match the gun. Remember that on your side, you can adjust it as much as you want. And also, if you have any specific gun mesh coming with a specific maybe animation exactly for this purpose, use your location and use your animation later, because I will also construct the animation. So we have a duplicated socket. Let's call it inverse. And let's make sure the inverted hand is located in the right place and has the correct rotation. Maybe let's just try to invert some axes. Maybe not this one. Nope. Let's maybe just rotate. Yeah, fits well. Okay, let's save this. And now let's return to our pistol blueprint and finally create the second grab component. And then we're gonna put the new socket name over there. Let's call it far. Yeah, now let's copy the name of the socket for it and just put it right here. So we've done with the socket. Now the animation, because that's the different location of the gun. And we're gonna need another animation for the hand. As I mentioned, I don't have any specific animation, so we're gonna just follow the steps as we did it before, and I will kind of construct it from the existing animations. So we're gonna need a new animation instance. Again, we have the idle here. I just duplicated the one for the previous grab component. And now let's see what we can take from here so it will look realistically. I think we can grab these two. Yeah. Let's just delete this. Now paste what we have. This time we will connect it with the idle because it's gonna work for us. and we're gonna just set up the fixed blending options. Let's remove this other blending option. We won't be using it. And again, the fixed blending here. This will just give us the feeling that we have the animation for holding the gun over there. Yeah, so not the full blend will give us some sort of visual grip. Again, you can use your animation, just put it right here and it will work. Let's now set up the reference to the new animation instance here. Now, about the two-handed grab exactly, how we're gonna do it? We will create a separate actor component that will externally manage, let's call it two-hand balance component, and this component will externally manage the two-handed grab case. So you add this component, you have two-handed grab. You don't want a two-handed grab to be an option, just don't add this component. And you won't have to change anything that already exists on the grab components or an actor, just add or remove this component. So we're gonna try to keep our solution modular. So the variables, we're gonna need to store the array of active grab components. So we're gonna store there all the grab components that are currently used for the grab. So technically in single player, as for our case, it's possible only to have that array of size 2 because you have two hands. Let's get those components from our owner. Here the class filter to the grab component. We're gonna iterate over them. And what we're gonna do, we will subscribe to the events when they are grabbed or dropped. And depending on that, we're gonna update our two-handed grab. On grabbed and on dropped. I need to connect the exact object over here. Yeah, on dropped. Now, in order to react to this, you have to type add custom event. Just select the name, and here you can just write the code that will execute. But in our case, there's one thing we still lack over here, because with this approach, we're gonna need to know exactly what component sends us that message. So there's a simple trick. Let's open this event dispatchers, and here you have the parameters, where we just gonna add the reference to ourselves as a parameter. So when the grab component sends the event to everyone that, hey, I am grabbed, he will also send the reference to himself inside this message. And everyone who will receive the onGrabbed or onDropped message will be able to know which grab component sent this message. We should recreate this call over here because otherwise it won't compile, and just put the reference to self like this. So onGrabbed, and now the same for the dropped. First add the parameter, and now let's find the call, it's over here. Let's remove it and recreate it again with the reference to the self. Just type self. Great. Now if we will go back here, if you're gonna type this, now you can see we have the component that sends the message as a parameter. And what we're gonna do is pretty simple. When the component is grabbed, we will add this component to the list of active grab components. And on the other hand, when it's removed, we're gonna remove it from this array. And we're gonna need one more function that we will call when the amount of active grab components changes. And here we're gonna just do the same like on dropped. Let's get our active grab components array, and here we're gonna call remove item. You can remove by index, but we need to remove by item. And we're still gonna call our newly created function. Let's connect it. Okay, so now we're gonna have the list of active components that are actively holding the item, And we will update the rotation of the item on the event tick. Let's get our active components. We're gonna check whether the length is more than 1. So technically we can have only 0, 1, or 2 hands. But you can use displays to handle maybe even 1 hand if you need additionally. We're just not gonna do it. And before we proceed, let's talk about math. So we have an object that has 2 grab components. Let's call it grab component 0 and grab component 1. Here we have our hand that will be snapped over there, and the motion controller will be in the same location and rotation that the grab component. But when it comes to the other hand, the motion controller with it gonna be in completely different place. So what we have to do? We have to calculate this vector between grab components. It can be the forward vector or not. The vector between the controllers, and then we just gonna calculate the angle difference, not the float angle just like 30, but rather the difference along each axis, and used it to rotate our object to exactly match the direction between the controllers. This is a 2-hand grip. Now let's implement it inside Unreal. So we can grab here 2 elements, 0 and 1. We can do that because we have checked that the length is higher than 1. And here from each of those, we're gonna first get the motion controller that is associated with it. And from each motion controller, we're gonna get the world location. So these 2 form that direct purple vector. It's a desired rotation of our object, which we'll have to achieve. It's not the case at the moment. And for the first grab component, remember, we will have to get its own world location. So this will help us to create 2 vectors. Let's use get direction, normal, so it also gonna be normalized. Right, so now we have purple and yellow vector from our presentation. And now let's use the function find between normals because we have them normalized. And that angle gonna be exactly the angle difference for us to add to our owner. So let's use add rotation function over here and just pass the angle between our yellow and purple vectors to this function. Cool. So this is the main code for rotation between 2 objects, but we gonna have to do one more little trick. So we're gonna add the boolean called be ignore pitch. Why ignoring pitch? Because we want our gun to stay upright. Because if we won't do that, if you will test this code with ignore pitch set to false later, you will see that you can kinda rotate the gun around itself, and even your scope will be facing down, which is definitely not what we want to achieve. So we will kinda help the object to be rotated between 2 objects, but still face up when it comes to the scope, for example. So we will just get the owner rotation and then call the set rotation. Here you can split inputs and outputs and just connect these 2 except the pitch. So pitch will remain 0. Cool, but what we have left right now is that one function that updates the grab. So this function gonna be called every time the amount of grab components changes and allow us to correctly perform grab on the more prioritized one or on the one that left. So we will make sure that the object is still grabbed as grab components desire to grab it. First, let's check this case here when we still have 2 hands grabbing our object. In this case, what we're gonna do, which means how did we get to this place? We get to this place when we received some event, and right now we might be grabbing the object by the hand that has lower priority. But we always want, remember that first variable we added to the grab component, and we want our object to be grabbed always by the grab component with the highest priority. So first of all, let's just copy this code. Let's rearrange them, and we're gonna just check their priorities. If the one with index 1 has the bigger priority than the element at index 0, and in this case we will just swap them in our array. And now probably let's add one more function that will just perform the top hand grab. Let's call it right here. Okay, now we need to handle the case when we have only one hand left. So for example, you were grabbing the gun with two hands, and now you released the one that holds the trigger. And we don't want the gun to be just attached in some weird way to the other one. We want the remaining grab component to be able to perform the grab by himself as he wants to do it. This will exactly give us the effect you've seen on the initial video I've shown you before. And here we can just use our element at index 0. Because if you remember before, we have checked whether we have the index 1 with higher priority, and if yes, we swap. So here we're going to call this perform grab function that in our case for the grab component will snap but will not call all this logic because we don't need it to be called twice. We have already grabbed before. That's why we have that component inside our active grab components array. Now let's add our component to the pistol. And here let's just select ignore pitch because it's a gun. And for the grab component that was originally there, we will set the priority to 1. So we want this to be the leading hand. The other will just have, oh, and the position should be correct. Also, let's set the free grab for that hand. All right. And here I have forgotten to add the reference to the motion controller because it's required by the function. So the perform grab will work correctly. And one more thing, I think I made a mistake over here. It should be add actor world rotation, not local rotation, because we operate in world coordinates here. It should remain mostly the same. We're gonna just replace the function. All right. Now, from the future, when I'm recording this, I can also tell you that I have forgotten to connect this. And inside the update grab function here should be 1. And the last thing, we want to perform our top hand grab in any case, whether we have those incorrectly positioned from the start or no. So let's replace this with sequence. There is one little improvement, I'm recording this from the future, that we have to make to this. So we are adding the world rotation to the actor, and this function will add this rotation to the center of the object. So in our case, we have this grab component and we use its location for the rotation. But the thing is that it magically is in the same location where the pivot point is. So the rotation will always work as intended. But if you would like to rotate it around any other grab component, like this one or any other point, it may not really work. So we're gonna need a function, rotate around point, that will allow us to rotate the object around any point in the world. We will add two variables, the point, that's gonna be vector, and the rotation to add. The math behind this solution is pretty simple. So first, we're gonna have to get the vector from our current owner, so from its pivot point, to the point around which we want to rotate, and then save it to local variable. So we just subtract the point, and we promote this to local variable. This will be the direction from our owner to the point, and we're gonna need it later. For now, we just save it, and then we will have to move our owner to this point around which we want to rotate. We can use just, let's get the owner and use set actor location over here. And we're gonna just pass the point over here. So imagine that we move the object along this direction to the opposite one, of course. Now we can rotate our object. This still won't be exactly the rotation around the point, but this is an important step. So we can just add actor world rotation over here. Let's connect it, and we're going to use the rotation to add the variable we pass to the function and just rotate the object. But how to make it a rotation around the point still? Because we have changed the location. Well, we will move our object back using the add world offset, but we're gonna not move it just back to the original location. We're gonna use this point vector, and we're gonna rotate it by the rotation 2. So we can use rotate vector, and this is how we're gonna return the object back. So its location will be offsetted 2, and this together will give us the rotation around the point result. Now we have to replace the original function that we were using over here to our newly created one. Let's connect our function like this, then just pass the rotation and the zero motion controller as the point around which we want to rotate. Cool. Now put your headset on, grab with one hand, another hand, and it works. If you release one hand, it grabs like this, another hand, free hand grab. So it looks like we have successfully implemented our two-hand grab balance component.